Hi, today we are going to be focusing on learning target 3 of our chemistry unit. We are going to be talking about how chemical bonds form and what valence electrons have to do with that. So first, let's talk about what we have learned already and where we're going next. So last time we met, we talked about what an atom is, what the periodic table is, and what an atom is made out of. But today we're talking about how atoms can join together to make more complicated structures like this DNA molecule. So you know that atoms are not just floating around randomly in our world. They join together to make more complex things. But how does this actually work? That's the theme of today. So uh, let's talk about what a chemical bond is. A chemical bond is a force that connects two atoms, or two or more atoms actually, together by gaining, losing, or sharing electrons. So if you don't remember what an electron is a negatively charged particle that's spinning around the nucleus or the center of an atom. Here, these arrows are all pointing to an example of a chemical bond. So you can draw a chemical bond using a ball and stick model like this. That line represents a chemical bond. In this diagram, this line represents a chemical bond. And in this diagram, these two electrons in between the two nuclei represents a chemical bond. And these are all actually water molecules. So I just wanted to show you the different ways that you can demonstrate or show a chemical bond. But basically, it's just a force that connects these atoms together. In reality, there's not really a stick in between these atoms. But when we draw them, we like to draw a stick to represent that chemical bond. This is what it more looks like in reality. Okay, so let's talk about energy levels in an atom. So each atom has a nucleus in the center as well as electrons spinning around the nucleus. Now, electrons aren't just spinning around randomly, they are organized into these electron shells, or we call them energy levels, okay? And there's actually a certain number of electrons that can fit in each level. So in the first level, or the first shell around the nucleus, it could only fit 2 electrons maximum. After that, there's a second energy shell that can hold up to 8 electrons, and the third shell around there, the third energy level, can also hold 8. So after the maximum number of electrons has been filled, it creates a new shell around it. So just remember that in each level, energy level around the nucleus, there's only a certain number of electrons that can fit into that energy level. Now, let's talk about why this matters. Well, first of all, let's talk about the electrons on the very outside of any atom. So in the outer shell of any atom, we have what we call the valence electrons. And valence electrons, these ones on the outside, are the ones that are going to be forming the chemical bonds like this. Okay, they're the electrons that are going to be interacting with each other, with other atoms, to form bonds like this. Okay, so and here's a picture of a valence electron. That red dot there, that's a valence electron. All the other electrons are in blue. They're called core electrons. Okay, so now let's talk about why chemical bonds form in the first place. So chemical bonds usually form between two different atoms because many atoms are really unstable if they have to exist on their own. Now, how does an atom become unstable? Well, an atom becomes unstable when it doesn't have a full electron shell. So remember we talked about these electron shells around the nucleus, and that there's a certain number of electrons that have to fill that shell in each level. So the first shell has 2 electrons, the second has 8, and the third shell has 8, etc. Now, if an atom is missing any of those electrons, it becomes unstable. And actually, the fuller the shells are, so the more electrons it has, the more full it is, and the more it has in each shell, the more stable it is. So atoms are constantly trying to get more electrons to be stable, and one of the ways it does that is it gains electrons by sharing those electrons with other atoms. And we'll talk about the different kinds of bonds later. But let me give you an example. So here are two atoms. This one's called oxygen. This one is called neon. I know it looks really similar, but if you go and count the number of dots or electrons around the nucleus, you'll find out that oxygen has only 6 valence electrons, so 1, 2, 3, 4, 5, 6, whereas neon has 8, 1, 2, 3, 4, 5, 6, 7, 8. So if you compare these two, neon is much more stable than oxygen because neon actually has all 8 valence electrons it needs to be stable. And you can see it's in the second shell. The second shell can hold up to eight electrons. Whereas oxygen, it's missing 2. It only has 6. So oxygen is a lot less stable. So oxygen is more likely to try to form a bond with another atom, like here. You can see here oxygen formed bonds with hydrogen because it needed 2 more electrons. So it shares them with the hydrogen atoms, okay? And this is why different chemical bonds form, the reason why. So this brings us to the question, why is it important to know how many valence electron an atom has, and what's an example? So if you know the number of valence electrons or electrons on the outside, you can predict how many bonds that atom can make. So we already know from the example of oxygen, because it has 6 and it needs 8 to be stable, it needs 2 more valence electrons. That means we can predict that it's going to get 2 more electrons from somewhere. So in this example, it got its 2 electrons from hydrogen, because hydrogen only has 1 valence electron, and hydrogen needs 2 to be stable, right? Because look, in the first shell, it has to have 2 electrons for it to be stable. So hydrogen also wants to bond because it only has 1. So this is a good relationship right here, because hydrogen can share an electron with oxygen and get 2 in its shell, whereas oxygen needs 2 electrons for it to complete its set of 8 in its second shell. So that's why it has 2 bonds with 2 hydrogens, so that it could complete its outer shell valence electrons. And so this is a very stable molecule because all of the atoms have the maximum number of valence electrons it needs. So I gave you an example with water, but you can actually see how many valence electron an atom has by looking at the periodic table. So here's the periodic table. You know that in every periodic table we have a chemical symbol, the actual element the symbol represents, as well as the atomic number and the atomic mass. So this atomic number becomes really important because this atomic number is the number of protons and electrons in that atom. So in carbon, we have 6 protons and 6 neutrons and 6 electrons, right? So if there's 6 electrons, and if you were to draw the atom, we know there's 2 in the first shell, and then that leaves us with 4 in the outer shell. That means it needs 4 more for it to be stable because we want 8 in the outer shell, right? So you can predict that carbon is most likely going to be forming 4 bonds, so it can get 8 electrons in its outer shell. Another way, a really quick way you can tell the number of valence electrons in the periodic table is by looking at the group number. Now, if you don't remember, a group is a column, each column in the periodic table, and each group has a specific number. So this is 1A, 2A, 3, 4, 5, 6, 7, 8. For our purposes, we're going to kind of ignore the B elements here in the middle. We're just going to focus on the gray part. So in the periodic table, the group number matches the number of valence electrons it has. So for example, in lithium right here, lithium is in group 1. I don't know if you can see this, but it's in group 1. And I just put this arrow here so you can see where on the periodic table lithium is. So Li is lithium. And it has 1 valence electron. And you can see that it's in group 1A. So because it's in group 1A, it has 1 valence electron. And that's the same for all the elements here. All the elements in group 1 have 1 valence electron. Let's look at another example. So oxygen again. Oxygen, if you can see here, here's O for oxygen. Oxygen is in group 6, and because it's in group 6, there's 6 valence electrons, 1, 2, 3, 4, 5, 6, and that's true for all the um, elements that are in this group. All the elements in this column have 6 valence electrons. Um, and you can use this rule for all the elements here. So for example, chlorine, Cl, is in group 7, it has 7 valence electrons. So using this information, you can predict how many bonds an element can make with another atom, right? And we'll talk about the different types of bonds next time we meet. But this is the basic information that I would like for you to know before we move on to learning more about molecules and how these complex structures get formed. Okay?